Welcome to Lesson 5, Ocean Currents.
Well, we have represented here today the sun and the earth.
Okay, so just a few things about the earth that you need to be aware of. First of all, the equator is this middle part that runs all the way around. The center, it splits it in half. So you have a top half, northern hemisphere, bottom half, southern hemisphere. This middle piece is what we call our middle latitudes. And then we have a North Pole and a South Pole.
Phew, that's a lot of information, Mrs. Dennis. So first question, should we go over the questions? Or just say that and just notice some things?
You're gonna notice or need to notice some information about the light and where it's shining and how it's shining, because you're gonna answer some questions.
And you're always welcome to pause and rewind the video to figure out the answers to those questions. I think that'll get you through question 3.
So you'll need to pause and answer question 3.
Okay, welcome back for question 4. Your teacher, that's us, in our awesome lab coats, are going to put our hands on the globe, and you would be doing this if we were here with you, or if you were here with us, but since that can't happen, no, improvisation. So first question, Mrs. Dennis. Let's see. Oh wait, we probably better field this first. It says, your teacher will invite you to put your hands on the areas of the globe that you think will be warmest and coolest. Are they? Well, I'm going to venture to say the coolest part of the globe is going to be over here, where the light isn't shining.
Pretty cool, I would guess.
Yeah.
Okay, I would guess that this front part right here is going to be the warmest. Oh yeah, pretty warm.
I'm going to compare it to this cold area.
Ooh, pretty warm.
This cold area. I need to be over here. Okay. What about up here? Do you think it's going to be warmer or cooler up here than down here?
I think it's going to be a little warmer.
Ooh, you're right. It's a little warmer up here. I wonder why that could be.
Yeah, definitely. Feel the heat. So I would venture to guess it has something to do with the way that the earth is tilted and the angle that the light is shining on it.
And you know, we have the earth set up here in summer. This is northern hemisphere summertime is the orientation of the earth here. Should we go through the questions?
Sure.
All right, Mrs. Dennis, why are some areas of the globe warmer than others?
Oh, I think we kind of talked about that. Has to do with the directness of the light coming from the sun, right? So the way that the sun hits certain areas are going to make them warmer than others, like over here that are not getting sunlight right now, right? Much cooler than when you have direct sunlight.
Yeah, and a way I explained this to a student a couple weeks ago was, this is a direct blow from the sun. It's hitting at near 90 degrees. All of the energy is directly coming here. But down here, where we said it was cooler than up here, down here, I would call it hitting at a glancing blow. Like it's not coming directly, it hits at an angle, and then goes off. And that makes it less warm.
And you'll notice the equator, that area stays pretty warm all the time. But if you look, when you turn the globe, it gets about the same amount of sun all the time.
Even when it would be winter in the northern hemisphere. The equator is still at a very direct angle to the sun. Question B. Are these the same reasons some areas of Earth are warmer than others?
Yes.
Question C, you're going to do. Why is Earth warmer at the equator than at the poles?
Oh, and I feel like we just gave you a big hint about that.
If you can't remember, can't think it up, maybe rewind. Question D, how does the sun's energy cause convection currents in the atmosphere?
What? What
Convection
are currents?
Well,
go ahead.
I think that heat's going to have something to do with it.
Absolutely. So currents, right, is air movement. So if you think about, we talked about just air in the atmosphere, wind, right? Air moving, and it does have to do with heat because heat causes air to warm up and wants to go up, wants to rise.
So remember when we had our tubes in lesson 4? Or what were they called? Convection tubes, right? Same name. And we had the candle in them, how fast that air with the smoke moved really fast because that air was warmer and it moved faster. So convection currents in the air are similar. When the air gets heated up by the sun, then it's going to want to move.
Right. Moves up. As it goes up, it starts to cool down. Cool air wants to fall, so then you end up with a cycle or a current. It's moving.
Very good. E, do you think the convection currents at the equator are just like the ones at the Arctic Circle? This is the Arctic Circle. I'm with Mrs. Dennis.
I'm going to say no, right?
And I think it's an easy answer because we already said it's warmer at the equator because of the direct. So don't you think then they would have more faster moving air?
Yes. Slow at the equator, at the poles.
I would bet that even when this gets heated really a lot in the summer, because it certainly doesn't get heated in the winter up here, when it gets heated in the summer, I'll bet that the convection currents don't get as warm maybe as the ones at the equator.
Yeah.
So they wouldn't move as fast nor as high.
Ever. I don't think they would ever.
Yeah. Yep. Okay, that is question 4. So you need to do 4C in your journal, and you've already done all of question 3.
Good luck.